Today we will talk about roots of real numbers. This is section 6-1 in your textbook. So our essential question for this section will be, how do you find roots of real numbers? So let's start off by talking about square roots. A square root of a number b is a solution of the equation x squared equals b. So the first thing we're going to learn is that every positive number b has two square roots. Okay? So we could have simply the square root of b, or we could have minus the square root of b. So let's take the example of the square root of 25. Okay? So say I've got the square root of 25. Now that could obviously equal plus 5, or it could equal minus 5. Now, one thing you need to know is that the positive square root is referred to as the principal square root of the number. So the principal square root of 25 in this case is plus 5. So now let's look at cube roots. So the cube root of a number b is a solution of the equation x to the third equals b. Now, one thing that's different about a cube root from a square root is that every number b, whether it's positive, negative, or a 0, has exactly one real cube root, okay? There is not the situation there was with square roots where you had a plus or a minus. The answer simply is the cube root of b, one solution. So let's look at an example. Let's say I want to know the cube root of 8. So I want the cube root of 8. That is simply equal to 2. That's it. There's no plus or minus 2. It is simply equal to 2. Because minus 2 would give you minus 8. So if I'm talking the cube root of 8, the answer is plus 2. Now, if I'm talking the cube root of minus 27, let's look at another example here. So let's say I've got the cube root of minus 27. The answer to that is simply minus 3. There is no plus 3. It's minus 3. Okay? So the cube root of a number has only one solution, all right? So now let's look at the general case where we're talking about the nth root. We've talked about the square root and cube root, so let's take it to the general case where we're talking about the nth root. So an nth root of b is simply the solution of the equation x to the n equals b. Now, there are, depending on whether n is odd or even, is going to make a difference with the number of answers you have. So if n is even and b is greater than 0, there are two real nth roots of b. This is much the same as it was for square roots, okay? So when n is even, b is greater than 0, there are two real nth roots of b. One of these is obviously the principal or positive nth root, and the other are denoted by being negative. Now there are two other examples. One would be the case where n was even and b is equal to 0. Well, the only way b can be equal to 0 is if the nth root of 0 is equal to 0. So in that case, if n is even and b equals 0, there is one nth root, and that is 0. The other case would be if n is even and b is less than 0. In other words, if b is a negative number, then there is no real nth root of b, okay? You cannot have an even root of a negative number. Now, if n is odd, there is exactly one real nth root of b, whether b is positive, negative, or 0. So this is the same thing as we had with cube roots. There's one answer, okay? So if n is odd, regardless of what b is, there's going to be one answer for the nth root. Alright, so let's look at some examples now and hopefully explain what we just talked about. Let's say we've got the fourth root of 81, okay? So I got the fourth root of 81. Alright, in this case, n is even and b is greater than 0, so that we have two answers here. We could have this could be equal to 3, positive 3, which is the principal fourth root, or it could be equal to negative 3. We have two possible answers. All right, let's look at the fifth root of 32. Now in this case, n is odd. Fifth root of 32 is simply going to be 2, because 2 to the fifth is equal to 32. And that's the principal root. There is no other root. Now what if we have the fifth root of minus 32? So we've got the fifth root of minus 32. Again, there's only one answer. N is odd. The answer for this one is going to be negative 2. And then one more. Let's say we've got the sixth root of negative 1. So I've got the sixth root of negative 1. Well, in this case, n is even, but b is negative. So therefore, there is no solution for this, because you cannot come up with a number that will give you the sixth root and have it come out to be negative. So there is no real solution for this, okay? So no solution. Alright, so these are examples of determining roots of real numbers. I would now like you to do oral exercises numbers 2 through 12, the evens only, so that's 2, 4, 6, 8, 10, and 12, on page 261, and post your answers in the Dropbox. Thank you.